can we do with vectors? The zero vector is a vector made up of all zeros. In 2 dimensions, that's just the vector 0, 0. So in 3 dimensions, guess what it's going to be?
0, 0, 0.
Yeah, we call that the zero vector, which is 0, 0, 0. Remember that a unit vector is a vector with a magnitude of 1, and we have those special unit vectors I and j, where I was 1, 0 and j was 0, 1. We can do that with 3 dimensions too. We can say that I is 1, 0, 0. J is 0, 1, 0. Those would have a magnitude of 1. I think they call the other one K. I gotta check. Yeah, K. K is 0, 0, 1. So we could write vectors in component form, which just with the pointed arrows, but we can also write them as an equation, right? So using these, I don't know where we can, I'm going to just put it right here. We can say that vector V, which we could write as V1, V2, V3. We like that form, right? We like the pointed arrows. But you could also write it as an equation. It's the same thing in terms of its unit vector. So you could say V sub 1I plus V sub 2j plus V sub 3k. And you guys didn't like the I and j stuff with vectors in 2 dimensions. You're probably not going to like it in 3 dimensions either. But it just means the same thing. It means if you saw this, you could just take the coefficients and put it back in component form and do all the same stuff. All right, I don't think they do a lot of I, J, and K stuff in this, but I just wanted to show you. What I really want you to do with vectors, just some basic operations. I want you to be able to add and subtract. I want you to be able to find magnitude, and I want you to be able to find dot product. That's it. No direction, no converting the unit vector, no crazy stuff. I just wanted to remind you of stuff we did with vectors in 2 dimensions. And when we added in 2 dimensions, do you remember what we did? Yeah. What did you say, Grady?
Look at that writing.
What?
The writing opportunity.
It's right here. This is what you have to do. If you add a vector to another vector, you just add the components. So in 2 dimensions, you only have 2 numbers to add in each one. And here we have 3 components. So we do V1 plus W1, V2 plus W2. I don't really want to write the minus, but you can do the same thing. But I'm just going to go like this. Can I do this? Plus or minus? Do this. Is that okay?
That's brilliant.
Boys. I'm just saying you can add or subtract, right? Like if it's adding, you add them, and if you subtract them, you could rewrite it down here and just change all the pluses to minuses. You guys are too busy hitting each other when I said that. No fun allowed. You guys. It was 10 days. It said 10 this morning when I came in, and now it says 10. My custodian keeps writing this up here, and I don't like it, and I keep erasing it.
Days is just stuck. Remember that? I wrote 8. Everything is.
When I came in this morning, it said 10 days, because my custodian keeps writing it.
Why? Why?
We shouldn't count the days, we should make the days count.
Oh.
Are you kidding? That's a Mr. Puckett quote.
I'm going to tell Zane to put that in this.
Oh, yes. You will be so happy. You can make that in your speech.
A wise bald eagle one.
I'm recording right now.
A wise eagle. So bald.
Here.
All right. On the test, if I say this, right, this is what I'm going to write. You have to know what that means, right? Like, you have to know the notation. It means the magnitude. It means the distance. And you just take the square root of, do you remember how to find magnitude of a vector? It is just distance formula. In component form is the distance from the 0 already, so you can just take each component squared, right? It's like you're subtracting from 0. So if you're taking the distance or the magnitude of vector v, you're just going to take v1 squared plus v2 squared plus v3 squared, right? 2 dimensions, the formula is this. 3 dimensions, the formula is this. Why is everything coming up? And then the last thing, that is dot product, right? That does not just mean multiply. Dot product means when you take v dot w, you actually just get a number, right? You don't get another vector out of it. And so when you do dot product, you take v1 times w1 plus v2 times w2 plus v3 times w3. Which means you don't get a vector, right? You don't get like the pointed arrows and a comma, like you get a number.
Number 1.
So then, it was kind of a trick that there's only 3 slides, because there's 4 examples on the next slide. But this is what your homework is, which hopefully will be a nice, easy way to end the chapter, maybe, along with midpoint and distance formula for 3 dimensions. If I gave you 2 vectors, I want to know that you can do these operations. Very similar to the stuff that you had to do on the last test with 2 dimensions and vectors. So if you add them, you just add them. 1 plus 3 is 4. Negative 2 plus negative 1 is negative 3. And 4 plus negative 6 is negative 2. You do need to use the pointed arrows as opposed to parentheses, because that lets people know that it's a vector and not just point. If there's a number in front, we call that a scalar in front of a vector. Remember that you just multiply the number in there, and then you can add and subtract. So it's kind of up to you if you just do it all in your head, or if you want to distribute the negative 2 in and then make that a plus. I don't know what you want to do. I usually do a little bit of work here. So 3 times v, I'm going to change that to 3, negative 6, 12. I tend to leave the minus, but you could just change that to a plus and distribute a negative 2, right? So that would become negative 6, positive 2, positive 12. Or if you leave the negative, all your signs would be different, yes? And then I just add them. 3 plus negative 6 is negative 3. Negative 6 plus 2 is negative 4. And 12 plus 12 is not 22. Yes?
So it's a negative, not a minus sign.
It's the same thing, right? Wouldn't this be the same as if I left it a minus and wrote that as 6, negative 2, negative 12? You see what I'm saying? Like you get the same answer? So if you leave it as a minus, and you only distribute a 2, you still have the minus there, so now you still get the same answer. 3 minus 6 is still negative 3. Negative 6 minus negative. So, is it a minus or a negative sign? Yes, right? A minus sign is a negative sign, because you could write every minus as plus a negative, so it's just however you want to see it. Number 3, that means magnitude, right? So I'm just going to take the square root of, make sure you're using W and not V, and I'm just going to square each one of those. So that's just going to be the square root of 9 plus 1 plus 36. When you square a number, it should always be positive. You should never have a negative number under there. So that's just the square root of 46. I don't want a decimal on that, right? If you could take a perfect square out, I'd want you to do that. But other than that, like that's the magnitude, the square root of 46. And then dot product, that's the one that maybe you might have to look at the formula for that again to remind yourself. But dot product, you're just going to get one number as your answer. So you just take and multiply the corresponding components, and then you add that together. So you would get 1 times 3 plus negative 2 times negative 1 plus 4 times negative 6. So 3 plus 2 minus 24 would be negative 19. So when you add and subtract vectors, or you multiply by a number in front of a vector, you get a vector out of it. But when you find magnitude, you get a number, because that's the length of the vector. When you do dot product, you get a number, not a vector. And so I think there's a multiple choice question about that today, like which one of these doesn't equal a vector. And it's just to remind you that these two don't equal vectors. That's it. Huh? How about that?
Look at your homework pages, please.
Is it not the right
It's
page?
just funny how you got 39 and 94.
Find the homework somewhere in the pages.
It's 93, I bet.
Yeah, it's either 93 or 39 and 40, one or the other.
I think it's 93.
I mixed the numbers.
93, that's what it was last.
There you go, it's the same one.
It was just funny.
Sometimes I do the wrong page number, like I start one page before, and the next day I've had kids, they're like, this was the wrong page. It was just the next page. Like, couldn't you just look ahead? Like, you really have no clue what section we're on? So no, this is just the next page. But that one is a good one.
Yeah, you just came to that.
Yeah. And it's actually, 93, 94. 23 through 28 all. You really don't have a ton of time in here, but it's just like those 4 problems that we just did, which means you have a good chance of getting that done, and 61 is a multiple choice question. So not a bad couple days of homework. Maybe not a bad day to have a homework quiz tomorrow to try to boost some grades up here. Which means if you haven't done your homework, you better do some homework. I don't know.
Can you tell us what
At least the last 2 days.
The easy part was the last 2 days, and the graphic part was the last.
Not the grabbing of points.
Even the 3D.
I'm not happy that you're playing with that when I'm teaching it. Don't lie, you're doing it while I was teaching. You're